Hello friends, in this video I will be explaining tree data structure. So it's a non-linear data structure where each node is connected to other nodes using pointers. So basically this is known as a node, and this node is connected to other nodes using pointer. So basically inside this node there are three things. One is data, second one is left pointer and right pointer. So we can store data in the node, and in the left pointer we can store the address of the node, like of the left node, and in the right pointer we can store the address of the right node. Okay, so it's a non-linear data structure because it cannot be accessed in a sequential manner like array. So if we look for tree terminology, there are certain things which we need to remember. The first one is the root node. So the node which is at the top of a tree is known as a root node. Now the nodes are connected with other nodes using an edge. Okay, and there is a leaf node. It's nothing but the type of a node which does not have left and right children. So basically if we look at this node, it does not have left and right children. But now if we look at this node having data 1, it have its left as well as right children. So leaf nodes are those nodes which does not have left and right children. Now this tree is being represented in this manner in programming. Okay, so basically this node, it consists of three things. One is left, right and data. So we'll be storing all the data in this area, and we'll be storing the address of this node in this area and the address of this node in this area. Okay, so if we look in this diagram, we find that this left will consist of an address of the left node, and right will consist of the address of this right node, and as a result it will form a tree like structure. So basically it's a kind of a binary tree which have two nodes at max. Okay, so there are various types of trees available like MW tree, B plus tree, but basically we'll be concentrating on binary tree because it's important in terms of interview purpose. So binary tree is a type of a tree in which each node at max can have two children. So basically there is a node and it can have at max two children, or it can have one children, or it cannot have any children. So this type of trees are known as binary tree. Okay, now we can represent this node, like we can represent the single node in terms of class node. So if we want to code like how we can create a binary tree, for that purpose we need to create a node representation, and using class we can easily represent a node. So this is the name of a node, and inside that the components of the nodes are data, left and right. So data will consist of any forms of data, either it can be user defined data or it can be integer value depending on the type of the problem. Left and right is a pointer variable, so it will consist of an address of node type, because the type of this left is node star. So it will be consisting of the address of node type variable. Okay, now this is very important. Like most of the students are confused regarding what is the height of a node, what is the depth of a node. Okay, so we'll be discussing this part. Now we need to understand what is height of node. So the height of a node is the path between deepest leaf node and that particular node. Okay, suppose this is a binary tree and I need to find the height of this node. Okay, so the height of this node is the path between deepest leaf node. So we need to search for the deepest leaf node, and this is the deepest leaf node. So the distance between the deepest leaf node and that particular node is known as the height of a node. So we can calculate like how many edges are there in this path. So there are 1, 2 and 3 edges. So basically the height of this node is 3. Now we need to find what is the depth of a node. So for finding the depth of a node, we need to calculate like how many edges are there between root node and that particular node. So we need to check from the root node to that particular node. So basically there are only one edge. So depth of a node is 1. So if you want to calculate the height of a node, you need to search for the deepest leaf node, and from that deepest leaf node calculate how many edges are there till that particular node. Now next is for depth of the node, you need to move from root to that particular node and count how many edges are there in that path. Now height of a tree. So basically we know that in order to calculate the height of a tree, first we need to go and search for the deepest leaf node. So this is the deepest leaf node, and from deepest leaf node we need to calculate how many edges are there till root. Okay, so if we want to calculate the height of a tree, then we need to find how many edges are there between deepest leaf node and the root node. And if we want to calculate the depth of a tree, then we need to calculate how many edges are there between root node to that of deepest leaf node. So basically height of a tree and depth of a tree both are same. So suppose if problem appears that write a program to calculate height of a tree. So it can easily be done because we know that the height of a tree is nothing but the distance or number of edges between root node to the deepest leaf node. Suppose the program is the next problem is find the depth of a tree. So the code which we have written like how to find height of a tree is same as that of in case of depth of a tree. So basically both are equal. So in this diagram the height and depth of a tree is 1, 2, 3 and 4 because this is the root node and this is the deepest leaf node and we need to calculate how many edges are there along this path. Okay, now next thing is level. So basically this is level 0, level 1 and this is level 2 and so on. So this is known as level of a binary tree. It starts from 0, then 0, 1, 2, 3 and so on. At each level, maximum node will be 2 to the power I, where I is a level number. So probably if suppose I'm standing on level 0 and I need to find like how many maximum nodes can this level accommodate. So basically 2 to the power level number is 0. So 2 to the power 0 is 1. So this level 0 will have only one node at max. Now suppose if I move from level 0 to level 1 and I need to find how many maximum nodes this level 1 can accommodate. So again the formula is 2 to the power 1 and the output is 2. So basically at max 2 nodes should be there, can be there in level 1. Now suppose from level 1 I move to level 2. So in that case 2 to the power 2 is 4. So basically at max 4 nodes can be accommodated in this level 2. So at each level maximum nodes will be 2 to the power I where I is the level number. Okay, so if the height of root node is 0, suppose there is a binary tree having single node. So in that case the height of this will be 0. So if the height of this is 0, we can relate between height and level. So basically height is equals to level number. Okay, so this is level 0, it means that this node is at height 0. This is level 1, it means that these nodes are at height 1. So we can assume the height of a root node as 1 as well as height of a root node as 0. It depends on the problem. So basically we'll be taking height of a root node as 0 and height is equals to level number. Now suppose you have given a binary tree, like suppose you have given a height say 5 or say 3 and you need to find how many nodes can this tree will be accommodating. So basically if your height value is 3, the formula will be 2 to the power h plus 1 minus 1 which is 15. So if okay, so for finding the maximum nodes at each level the formula is 2 to the power I and for finding total number of nodes, the formula is 2 to the power h plus 1 minus 1. Next is types of binary tree. So we know that binary tree is a tree in which each node can have at max two children. So it can be possible that a node does not having any children, or it has one children, or it can have at max two children. So now the binary tree is divided into mainly four types. One is full binary tree, perfect binary tree, complete binary tree, and skew binary tree. So in case of full binary tree, like, first, before understanding the types of binary tree, we need to understand the concept of internal and external nodes. Okay, so all the leaf nodes in binary tree are external node. So so in this diagram, this are external nodes because these are leaf nodes, and remaining nodes are internal nodes. Okay, so nodes are classified into two. One is external and other one is internal. External nodes are the leaf nodes, and internal nodes are the remaining nodes except leaf nodes. Okay, now in case of full binary tree, if, like, all the internal nodes will have two children. Okay, so suppose we know that this is the leaf nodes, these are the leaf nodes. So the remaining nodes are internal nodes, and yes, all the internal nodes are having two children. So these are internal nodes, and it must have two children. So basically, the definition of full binary tree is, it's a kind of a binary tree where all the internal nodes must have two children. Next is perfect binary tree. So in case of perfect binary tree, again all the internal nodes must be having two children, and the leaf nodes must be at the same level. So these are the internal nodes, this node, this, and the root. These are internal nodes, and it must have two children. So if we see the root node, yes, it's having two children. This and this are the children of root node. If we see this as an internal node, yes, it has also two children. This and this are the children of this node. Okay, so all the internal nodes must be having two children, but the level of the leaf nodes must be same. So in that case, these are the leaf nodes, and yes, the level is same. That is, like, the root node has level 0, then 1, then 2. Level is 2, and it's same for all the leaf nodes. Next is complete binary tree. So in case of complete binary tree, all the levels must be filled with the nodes. Okay, must be filled with the maximum nodes except the last level. If there is a node, then we must start filling that level from the leftmost side. Okay, so basically, if suppose I'll be taking next example, suppose this is a complete binary, suppose this I'll be making a complete binary tree. Okay, so this is a complete binary tree. Why? Because suppose this is level 0. So yeah, this level 0 is having the maximum node, that is 2 to the power 0 is 1. So yes, it's having one node. In case of level 1, the level 1 can accommodate at max 2 nodes. And yes, there are 2 nodes. But now in the last level, it must starts filling from the leftmost side. Okay, now suppose I'll be making another binary tree. So in this case, this is not a complete binary tree. Why this is not a complete binary tree? Because in the last level, the nodes must start filling the leftmost side first. Okay, then only after filling the leftmost side one by one, it can move till the end of the level. So this is known as the complete binary tree. So in complete binary tree, all the levels are filled completely except possibly the last level. If it is unfilled, if the last level is unfilled, in that case, it must be start filling from the leftmost side. Now next is skew binary tree. Skew binary tree is a kind of a binary tree where, like, the nodes are connected to other nodes in one direction only. So it's like in leftmost side only these nodes are connected. So this is known as a left skew binary tree. Now in case of right skew binary tree, in rightmost side only the nodes will be connected. So these are the most important types of binary tree, and this is all about introduction to tree data structure.